Osmoregulation is all about balance. A fish's internal fluid environment may not match the fluid environment in which it lives. What this means is that the concentration of solutes in the fish's cells is not the same as the solute concentration in the water. To maintain homeostasis, fish must maintain a constant-ish water and solute concentration. Whatever the external conditions are will ultimately influence the fish's internal state. Let's start off with understanding osmosis and osmolarity. Osmosis is the movement of solvent molecules through a membrane from a lower concentration to a higher concentration. The main goal of this process is to balance the concentrations on both sides of the membrane so that they are somewhat equal. In addition, osmolarity is how many solutes there are per amount of water. We can think of this as a ratio of solutes to water. What is osmoregulation? Osmoregulation manages solute concentrations and stabilizes the loss or the gain of water. The cells of a fish, and all cells in general, need a certain balance of the loss or the uptake of water. We should also discuss tonicity, which is how different solute concentrations affect the movement of water through osmosis. And ultimately, this will affect osmoregulation in fish. A hypertonic solution refers to a solution that is higher in salt concentration and therefore lower in water concentration or water potential. We can relate this back to fish that live in marine environments, aka saltwater. As we know, solutes move from a lower concentration to a higher concentration. Since the salt water surrounding the fish has a higher salt concentration and lower water potential than the fish's internal environment, the fish will expel water from within its body to equalize the concentrations of salt and water on both sides. To mitigate the loss of water from their bodies, they drink large amounts of seawater to compensate. However, since the water they drink is high in salt, the fish must excrete them. For example, fish secrete the extra salt they take in through chloride cells in their gills, which actively transport excess salt back into the seawater. Also, these fish excrete salt in their urine, which makes it highly concentrated because they do not want to lose any more fluids than they already do through osmosis. Next, we have a hypotonic solution. In this case, the solution has a lower salt concentration, meaning a higher water potential. Freshwater fish, for instance, live in a fluid environment that is hypotonic to the fish. Therefore, the fish has a higher salt concentration than the surrounding water. As a result, water will move from the external environment into the fish's body, or more specifically their cells, through osmosis. Freshwater fish can easily become overhydrated if they do not properly balance this increased intake of water. Because they intake so much water, there is little to no need for them to drink water. Additionally, their urine is highly dilute since they must expel the excess water within their cells to maintain homeostasis. Since they intake so little salt from their environment passively, freshwater fish actively absorb salts through chloride cells in their gills.